Welcome back to my channel. Today we are going to discuss a problem on Newton's law of cooling. So, what does this Newton's law of cooling states? Newton's law of cooling states that the rate of change of temperature of a body is proportional to the difference of the temperature of the body and that of the surrounding medium. So, so we are going to solve a problem based on Newton's law of cooling. Okay. So now, so according to Newton's law of cooling, according to Newton's law of cooling, d theta by dt is equals to minus k into theta minus theta naught. So this is according to the Newton's law of cooling. So where theta is the temperature of the body and theta naught is the temperature of the surrounding medium. So now to solve the problem, so what we have to do is we have to use the variables separable method. So we will move the theta terms to d theta side. So it becomes equation 1 is changed as d theta by theta minus theta naught is equals to minus k dt. Okay, so here we are going to use the variable separable method. So moving the uh, terms. So now taking integration after moving theta terms towards the d theta side. So now we will take the integration on both sides. We will take the integration on both sides. So d theta by integration of d theta by theta minus theta naught. So this is ln of theta minus theta naught. So here minus k is a constant. So this is equals to minus k. So minus k is a constant, so it comes outside of the integration, it is minus k. So the integration of dt is t plus the constant, you can write it as ln c. Okay. So now here we have two ln terms, we will move the ln terms to one side. So it will be ln of theta minus theta naught minus ln c equals to minus. Okay. So ln a minus ln b. So ln a by b. So this is ln of theta minus theta naught upon c equals to minus. So now we will convert this logarithmic function into an exponential function. So the base of ln is e. So therefore we can write it as theta minus theta naught upon c is equals to e power minus k. So the base of ln is e. So therefore you can convert this logarithmic function into an exponential function. So therefore theta minus theta naught upon c is equals to e to the power raised to minus kt, right? So after this, so now what happens here from here? So now we will move the denominator to the right hand side. So therefore it changes as theta minus theta naught is equals to c into e power minus c into e power minus. So this is number 2. So now we will be using the conditions given in the problem. So the first step, what we have to do, you have to write down the equation of Newton's law of cooling. Then we will use the variable separable method, and we will get this equation: theta minus theta naught is equals to c into e power minus kt, where theta is the temperature of the body and theta naught is the temperature of the surrounding medium. Okay, so now we will use the conditions given in the problem, and we will find the temperature of the body after 40 minutes. So what is the question here? A body is originally at 80 degrees centigrade and cools down to 60 degrees centigrade in 20 minutes. If the temperature of the air is 40 degrees centigrade, find the temperature of the body after 40 minutes. So now we will be using the given conditions. So what is the given condition? A body is originally at 80 degrees centigrade. So what is mean by a body is originally at 80 degrees centigrade and it cools down to 60 degrees centigrade in 20 minutes. That means here initially at time t is equals to 0. So at time t is equals to 0, 0 minutes, 0 minutes. What is the temperature? Body is originally at 80 degrees. Theta is equals to 80 degrees centigrade. So that is the first condition given in the problem. So body is originally at 80 degrees centigrade. So that condition we are going to use. Then next condition we'll use this one. Cools down to 60 degrees in 20 minutes. Okay, now if the temperature of the air is 40 degrees centigrade, the temperature of the air is 40 degrees centigrade means the temperature of the surrounding medium. So theta naught is given. Theta naught is how much? Theta naught is equals to 40 degrees centigrade. Okay, 40 degrees. So now we will put this values in equation number. So what happens, you see here? So theta is 80. So put in. So what happens, you see here? Theta is equals to 80 minus theta naught is 40 is equals to c into e power minus k into t. Time is 0. So here 0. So the 80 minus 40 is 40. 40 is equals to c into, so e power 0 is 1. So therefore we will get, this is e power 0 is 1. So therefore what we get? So therefore we get c is equals to 40. C is equals to 40. So this is number 3, right? So next, what we are going to do, we are going to use another condition. So body is originally at 80 degrees centigrade. So we have done that one, and now it cools down to 60 degrees centigrade in 20 minutes. So now what is the time? So at so we'll use the second condition. So therefore at time t is equals to 20 minutes. What is the temperature of the body? Theta is equals to 60 degrees centigrade. Okay. So now we will put these conditions in number 2. So put in into put into what happens here? So theta is equals to how much? 60 minus theta naught is the temperature of the surrounding medium, so that is already given. Theta naught is 40 is equals to C, we already got now, just got C value 40 into e power minus k into t, time is 20, minus 20 k, right? So we have just put these values, C value, T value, theta and theta naught value in equation number. So 60 minus 40 is how much? 20 is equals to 40 into e to the power minus 20k. So now simplify this one. So 20 upon 40 is equal to e power minus 20k. So cancel 1 upon 2 is equals to e power minus 20k, right? So now we have to find out the value of k here. So what we will do, we take ln on both sides. So this is exponential function, we will convert it to logarithmic function. So take ln on both sides. So ln of 1 by 2 is equals to ln of e to the power minus 20, right? So this is equals to ln 1 upon 2 is equals to ln e to the power minus 20k. This will become minus 20k, right? So now we have to find the value of k. So therefore, move this minus to this side. So minus ln 1 by 2 is equals to 20k. So minus ln 1 by 2, now this minus goes to the power. So it becomes ln 2. So this minus 1 is raised to the power of 1 by 2. It becomes 2 by 1. So it is ln 2 is equals to 20k. So therefore, we have a is equals to 1 by 20 ln 2. Ln 2. So this is number 4. Number 4. So now we got the values of C and K. So now once we got the values of C and K, 3 and 4, we put 3 and 4 in equation number 2. So now put put 3 and 4 in put 3 and 4 in 2. So we are going to substitute the value of C and we are going to substitute the value of K in equation number 2. So what happens now? Therefore, theta minus theta naught is equals to, what is the value of C? C is 40 into e to the power minus, what is the value of K? K is equals to 1 by 20 ln 2. So 1 by 20, 1 by 20 ln 2. So e power minus k. So this is into t. So this is equation number 5. So now using the equation number 5, we'll find out the temperature of the body after 40 minutes. So now from this equation, we will find out what is the temperature of the body after 40 minutes. So now, so what is the temperature of the body after 40 minutes? That means we have to find out the theta. So we have to find out the temperature of the body, that is theta, after 40 minutes. So therefore here, so therefore at t is equals to 40 minutes, comma. So therefore theta minus, so theta naught we already know it, okay, temperature of the surrounding medium, that is 40. So that is 40 my is equals to 40 into e to the power minus 1 by 20 into ln 2 into t. So what is t? T is 40. So here 40 minus. So what happens here? Theta minus 40 is equals to 40 into. So here 20, here 40 cancel. So it will be cancel 2 times. So it will be e to the power minus 2 ln 2 minus 2 ln 2. So therefore theta minus 40 is equals to 40 into. So now I will take this minus 2 to the power of 2. So it becomes e power ln 2 to the power minus 2. So 2 to the power minus 2 is how much? E power ln f of x is f of x. So therefore theta minus 40 is equals to 40 into e power ln f of x is f of x. So that is 2 power minus 2. So it is 2 power minus 2. So theta minus 40 is equals to 40. So 2 power minus 2 is nothing but 1 by 2 square, right? So theta minus 40 is equals to 40 into 1 by 4. So we can cancel it. So theta minus 40 10 times, right? So then we have theta is equals to 10 plus 40. So theta is equals to 50 degrees centigrade. So that is the temperature of the body after 40 minutes. So the temperature of the body after 40 minutes is 50 degrees centigrade, right? So this is the procedure to find the temperature of the body using the Newton's law of cooling, right? Hope you understood. Thank you for watching, and do not forget to uh, hit the like button and as well as share with your friends. Thank you.